Newton's third law of motion. In my previous video, I explained Newton's first law and second law of motion. So I will explain you this law of motion with the help of example. You can check in this figure a person is kicking a football. So person is applying a force on a football. So that force is known as which force? Action force. Same force will be applied by a football on person and that force is known as reaction force. Now second example, you can check in this figure a person is swimming in a swimming pool. So he is applying force on water in backward direction. That force is known as action force. And same force will be applied by a water on a person. That force is known as reaction force. Now third example, this figure is also given in NCERT. In this figure, there are two spring balance. This is spring balance A and this is another spring balance B. Both the spring balance are entangled with each other. B spring balance is connected with the rigid support and A spring balance is stretched by a person. When person will stretch the spring balance, now you have to tell me that both the spring balance A and B will show the same reading or different reading. Yes, both will show the same reading. Why both will show the same reading? Because A will apply force on B. So whatever force A is applying on a B, that force is known as action force. Same force will be applied by B on a A. That force is known as reaction force. It means that for every action there will be equal and opposite reaction. So now we will take the definition of Newton's third law of motion. To every action there is an opposite and equal reaction. Like you can check in action, whenever action is acting in this direction, reaction will act in which direction? Opposite direction. And same amount of forces will be there. Like A is applying suppose 15 Newton force on B, B will also apply 15 Newton force on A. That's why it is written equal reaction and opposite, because you can check both the forces are acting in which direction? Opposite direction. If one is acting in east direction, another is acting in which direction? West direction. Now we will take some important point of Newton's third law of motion. Now you can check this figure. In this figure, a nail is driven in a wood with the help of hammer. So what hammer is doing? Hammer is applying force on nail. So nail will also apply force on hammer, because you have studied Newton's third law of motion. To every action there is an equal and opposite reaction. Now what are the important points of these laws? The first is action and reaction forces are equal in magnitude and opposite in direction. Like in my previous slide, I explained you that both the forces will be equal in magnitude. Whatever force is applied by the hammer on a nail, same amount of the force will be applied by a nail on hammer. Now you can check. In this figure, hammer is applying a force in a downward direction and nail will apply force on hammer in which direction? Upward direction. Now second point, these forces act on different objects. You can check in this figure also. Like in this figure, how many objects are there? Two objects. One is hammer and the second is what? Nail. Third is action and reaction force pair don't cancel. We can't cancel these forces. Why can't we cancel? Because these forces are acting on two different objects. One is hammer and the second is nail. Like suppose if a person is pushing a truck, so the two things are there on which force is applied. One is truck and the second is person. So that's why we can't cancel these forces, because these act on two different objects. Now we will study applications of Newton's third law of motion. Like we have studied applications of Newton's first law, second law. In the same manner, we will study applications of Newton's third law of motion. So first application is walking. We push the ground, due to which ground pushes us forward. When we are walking, so what are we doing? We are pushing the ground in which direction? In a backward direction. That's why ground pushes us in which direction? Forward direction. Now you can check that. Now in this, what is happening? A person is pushing the ground, and that force is known as which force? Action force. Same force will be applied by a ground. That force is known as which force? Reaction force. So like if a person is applying 10 Newton force on a ground, the ground will also apply 10 Newton force on a person. Now second application, in swimming, we push the water backward, due to which water pushes us forward. Like when we are doing swimming, we push the water in which direction? Backward direction. Yes. So what is that force? That is action force. And the water pushes us forward. That is which force? Reaction force. Yeah. Now the third application, as the sailor jumps in a forward direction, the boat moves backward. You can check in this figure. In this figure, what is happening? A person is pushing the boat in which direction? Backward direction. So that force is known as which force? Action force. Due to which boat pushes him in which direction? Forward direction. And that force is known as reaction force. So there are more examples, and you can relate more examples to the Newton's third law of motion. Now I will take why a gun only recoils when a bullet is fired. Now what is happening in this? Now you can check that whenever the gun will be there, so gun will be having less acceleration, and while the bullet will be having more acceleration. So now you can check in this figure what is happening here. Bullet is traveling more distance and the gun is only recoiling. What is the reason behind it? You have studied Newton's second law of motion. So according to Newton's second law of motion, F is equal to ma. And when F is equal to ma, it means A is equal to what? F upon m. It means acceleration is inversely proportional to mass. Acceleration is inversely proportional to mass. It means when the mass is more, acceleration will be less. Now in this figure, what is happening? The mass of the bullet is less, due to which acceleration will be more. While in bullet if we are taking, while in the gun if we are taking, the gun mass is more, due to which acceleration is less. Now, so mass of the gun is more, due to which acceleration is less. So if we are asking about the bullet, why there will be more acceleration in the bullet? Because in the bullet mass is less, due to which acceleration will be more. I will explain you activity 9.4. It is also given in NCERT. Now you can check in this figure. On this cart, one girl is standing, and on this cart, one boy is standing. Now in boy's hand, a bag of sand is there. When he will throw a bag of sand, what will happen? There will be movement in the cart. And when a girl will receive this bag of sand, there will be also movement in the cart. Now in the next figure, there are two girls standing on this cart. Now how many girls are there? Two girls are there on this cart. And on this cart, only one boy is standing. Now you have to tell me that in which cart more movement will be there. On which boy is standing or on which girls are standing? Yes, very good. On which only one boy is standing. Why? Again the same. According to Newton's second law of motion, F is equal to what? ma. It means A is equal to F upon m. It means acceleration is inversely proportional to mass. Now you can check. In this case, mass will be more, due to which acceleration will be less. If we are asking for this cart, on this cart only one boy is standing. So mass is less, due to which acceleration will be more. So in this cart more movement will be there, more acceleration will be there, while in this cart less acceleration will be there. Now I will take another activity, activity 9.5. Now in this you can check, there is a balloon, yeah, and on this balloon we will paste a straw. Before pasting a straw, what we will do, we will inflate it and we will tie it with the thread. Then we will paste a straw in this. Then after this, we will pass a thread through the straw, and this thread is connected to two rigid support. Is it clear? So again I am telling, this is a balloon, it is inflated, then we are pasting a straw, and through this straw we will pass a thread, and this straw thread is connected to the two rigid support. Now what will happen? When we will open the thread of the balloon, the air will move out from the balloon, and when air is moving out from the balloon, it means the balloon is applying a force on the air, and that force is known as which force? Action force. And when a balloon is applying force on the air, it means air will also apply force on the balloon, because you have studied every action has equal and opposite reaction. So air is applying force on a balloon, and that force is known as which force? Reaction force. Now tell me, in which direction the balloon will move? Backward direction or forward direction? Yes, very good. It will move in which direction? Forward direction. Because air was moving in which direction? Backward direction. That's why balloon will move in which direction? Forward direction. Now I will explain activity 9.6. Now in this figure you can check, there is a test tube. This test tube is filled with water, and then we will cork it. And this test tube is connected to this clamp stand, and then we are heating it with the help of burner. So when a water is heated, so what is produced? The water vapor will produce, and this water vapor will apply force on a cork. So when the water vapor will apply force on a cork, so cork will move what? Cork will move in forward direction. So whatever the water is applying force on the cork, what is that force called? That force is called action, and that is applied on what? Cork. So when a cork is applying force, when a test tube is applying force on the cork, so cork will also apply force on a test tube. What is that force called? That force is called reaction, and that will be exerted on test tube. It means for every action there is equal and opposite reaction. So test tube was applying force on cork, cork was applying force on the test tube. But tell me, in which case you will see more movement, in the cork or in the test tube? Again, with the help of same reason, according to Newton's second law of motion, F is equal to ma. It means A is equal to F upon m. Acceleration is inversely proportional to mass. Now tell me कि more acceleration किस में produce होगा? In the cork or in the test tube? In the cork, acceleration will be more. Why? Because this mass is less. And in test tube, mass is more, due to which acceleration will be less.